On the 10th of March, Ethiopian Flight ET302 operating with a brand new Boeing BA 737 MAX 8 crashed shortly after departure, killing all people on board and marking the second fatal Boeing 737 MAX 8 crash. In the aftermath of the previous crash, a lot of misinformation was put out with maintenance logs of the crashed jet circulating that were not authentic, and plenty of investors deemed themselves air crash investigators without having the proper knowledge on aircraft and system design. Sourc, The New Yorker. When analyzing the Lion Air Boeing 737 MAX 8 crash in October 2018 using my aerospace engineering background, I provided a look at the stability systems of in aircraft and explained what changed on the Boeing 737 MAX, as well as my view on one of the key added systems that seems to be causing troubles on the Boeing 737 MAX. In this report, I will discuss what is known about the Ethiopian Airlines Boeing 737 MAX 8 crash, the plagued stability system, the certification, and the global grounding of the Boeing 737 MAX. All of these subjects will be discussed from a technical point of view. In a separate report, I will be providing my view on possible costs of the global grounding of the Boeing 737 MAX. Boeing share price has come down since the Boeing 737 MAX 8 crash with Ethiopian Airlines. Boeing shares have lost 15% of their value. Having two crashes within a matter of months is extremely worrisome, but what we do see is that the share price decline, which is almost solely driven by news regarding the Boeing 737 MAX crashes, is relatively timid for investors with a long-term view. Obviously, if a worst-case scenario is being considered, the downside, going forward, is significant. But if you currently went solely by the headlines, you would think that Boeing has lost half of its value, and that is not the case. Given the current circumstance, I do believe the downward pressure on shares is more than justified. After all, the Boeing 737 is Boeing's cash cow and its most scalable aircraft program. With the lower share prices, I don't feel that the risk-reward profile has improved. After all, there is a risk of cost growth, which will almost certainly be present due to the grounding of the Boeing 737 MAX. Ethiopian Airlines Flight ET302 Source, Flight Global. Ethiopian Airlines Flight ET302 was a flight from Addis Ababa to Nairobi. The flight is usually operated with either a Boeing 737-800 or a Boeing 737 MAX 8, and on some occasions even a Boeing 787. On the 10th of March 2019, shortly after takeoff, the pilot of a Boeing 737 MAX 8 with registration ETAVJ requested a return to the airport of Addis Ababa due to technical issues. However, 6 minutes after departure, the airliner, while cleared to return to the airport, crashed, killing all 149 passengers and 8 crew members on board. No adverse weather conditions were reported. Shortly after the accident occurred and with no granular data available, I was already asked to cover the crash and comment on the cause. At that stage, there was very little information available that gave an indication of what was a possible cause of the crash, and I did not want to feed into or spark any speculation, and so refrained from connecting the two crashes without clear evidence. Currently, more information is known, but there has been no release of even a preliminary report, which is issued within 30 days after a crash. The fact is, however, that this crash marks the second one with a Boeing 737 MAX 8 in 5 months, as well as the second crash since commercial service entry. For an industry that can normally pride itself with an impressive safety record, this is reason for concern. Shortly after the crash, we observed that both accidents occurred after takeoff during the climb away from the airport, that both flight crews intended to return to their departure airport but were unable to do so, and that both flights were carried out using brand new Boeing 737 MAX 8 aircraft. Later, it was also found that the horizontal stabilizer position was in a nose-down position similar to what happened to the Lion Air MAX 8, and we found the speed to be unusually high. The aircraft, a Boeing 737 MAX with registration ETA-VJ, was delivered to Ethiopian Airlines on the 15th of November, meaning that it was a little over 100 days old at the time of the crash. It is important to take into account that, without the information on the stabilizer position and/or global information communications between the air traffic controllers and the flight crew, one could only guess or speculate that these crashes might have had the same cause. Boeing 737 MAX, more than new engines. One of the reasons the problems with the Boeing 737 MAX are somewhat of a surprise is that the Boeing 737 Next Generation has a good safety record, and the Boeing 737 MAX is often seen by others as a re-engined version of the Boeing 737 Next Generation. Reality, however, is slightly different. The Boeing 737 MAX used CFM LEAP 1B turbofans, which are more efficient than the CFM 56-7B series used on the Boeing 737 Next Generation. MAX also had some cleanup done around the tail cone of the aircraft, and it uses an advanced winglet design. These elements reduce the fuel burn of the aircraft, but what is not often considered is the influence this has on stability of the aircraft. Figure 1. Typical setup. Source: Aero Analysis International. When reading the following 4 paragraphs, please keep an eye on Figure 1 to get a better visualization. The stability of aircraft. Keep in mind, there are different kinds of stability, has a lot to do with moments around the center of gravity. One of those important moments is the pitching moment. What we see in Figure 1 are the forces acting on an aircraft. Each of these forces has an arm, which is nothing more than the difference between the point where the force applies and the CG, the point where the full weight of the aircraft is acting. Ideally, aircraft have a center of gravity that is placed in front of the center of pressure of the wing, which is the point where the resultant lift force is applied. The lift force creates a moment around the center of gravity, CG, which is balanced by a down force on the tail. What this particular setup with the CG in front of the center of pressure is good for is a stability. The force on the surfaces scales with the velocity squared. If suddenly the airspeed decreases, the downforce decreases on the horizontal stabilizers, which can be considered small wings, and the aircraft will pitch down slightly to regain velocity in order to provide the required forces to keep the aircraft flying steadily. The same, but in opposite sense, holds for a sudden increase in velocity. This is known as positive static stability. Additionally, if the CG does not lie on the same line with the point where the thrust force is applied, there also is a pitch-up moment from the turbofans. That is where the new turbofans play a role. The new turbofans are not only more efficient, they are also more powerful and placed slightly higher and more forward on the wing. The result is that the nacelles generate some more lift in front of the center of gravity, which works as slightly destabilizing, and the more powerful turbofans generate a bigger pitch-up tendency for the aircraft. The reason I am going more in detail here is that, in order to understand what possibly could have gone wrong, why it went wrong in the role of the horizontal stabilizer, stability characteristics and systems should be well understood. It is important to have a stable aircraft that doesn't contribute to further destabilizing behavior when moved from its equilibrium point. It is possibly one of the hardest things for which to naturally or aerodynamically design the aircraft. That is also the reason aircraft and primarily fighter jets can nowadays be designed with unstable behavior and the aircraft is stabilized by computer systems. This improves maneuverability characteristics. This is especially important for fighter jets. For passenger jets, designing aerodynamically stable aircraft is still desired and unstable characteristics can be handled by augmentation systems if needed. Having a forward CG has some stability benefits. The CG, however, is not a fixed point and changes based on loading and even changes as the aircraft consumes fuel from its tanks. In an aircraft that flies nearly empty, the CG will shift more aft and that will ultimately result in a reduced moment arm for the tail force and lift force, and less tail force, resulting in less control force required by the pilot. This can cause overcorrections on the yoke, stick and more difficulty in recovering the aircraft from stalls, due to the shorter arm between CG and the center of pressure, while the elevator effectiveness for pitching reduces. This, however, is not bad design or dangerous. The aircraft should be easily operable within the limits set by the manufacturer. Maneuvering characteristics augmentation system. To correct for the pitch-up tendency generated by the turbofans, Boeing introduced a new system called MCAS, or Maneuvering Characteristics Augmentation System. Before we explain what the system does, we need to look why Boeing implemented it. So, we need to look at some of the changes Boeing has made to the Boeing 737 MAX. The Boeing 737 MAX makes use of bigger diameter turbofans that have been mounted more forward of the CG, and it has a longer nose gear strut to accommodate the bigger turbofans. Those are items that add weight to the aircraft in front of the CG and would make the aircraft pitch down. So, it changes how the aircraft would handle as compared with the previous generation Boeing 737. Additionally, there is quite a difference in the thrust capabilities. The turbofan powering the Boeing 737 NG series, the CFM56-7B series, has a continuous thrust of 115.2 kN, while the CFM LEAP 1B series that powers the Boeing 737 MAX has a continuous thrust of 127.6 kN, which is a 10% increase. So that would create a pitch-up moment that the Boeing 737 NG has to a lesser extent. Additionally, these bigger turbofan diameters possibly cause the nacelles, the housing of the turbofan, to generate lift or more lift at higher angles of attack, the angle between the aircraft body or wing chord and the relative wind, inducing a further pitch-up moment. This all adds to the instability of the aircraft and makes the aircraft harder to control at higher angles of attack during high-thrust situations, since the aircraft will tend to pitch up while stall prevention or recovery requires a pitch-down motion. The particular combination of high thrust and high angles of attack is typical for the takeoff phase of the flight. The MCAS is the system on the Boeing 737 MAX that went from an unknown system to the most known system on the aircraft. Fact is that if there had been no crash, nobody would have known that the system had malfunctioned or that it had even existed. Figure 2, Primary Flight Display Boeing 737, Source, Wikimedia, as mentioned, because the new turbofans cause a pitch-up tendency for the aircraft, which can be increasingly difficult to counter at higher angles, Boeing implemented the MCAS, which uses the angle of attack sensor. If the sensor senses an angle of attack exceeding a certain variable threshold, it will command the stabilizer to push the nose down in order to prevent a stall. The angle of attack information is shown on the primary flight display on the little gauge on the upper right. In Figure 6, it shows an angle of attack of 4.2 degrees. This is an optional feature. Figure 7, part of the horizontal stabilizer on an Embraer. Source, Wikimedia. The MCAS uses the horizontal stabilizer to move the stabilizer up by 2.5 degrees, resulting in a pitch-down tendency for the aircraft. So the system intends to directly counteract the unstable pitch-up tendency of the bigger and more powerful turbofans. What seems to have happened for the second time now is that the nose of the aircraft has been pushed down, likely due to wrong input from an angle of attack sensor. Boeing's role during the first crash in October. I was already critical of Boeing's role in MCAS design, something that hasn't always been appreciated by Boeing investors. Boeing introduced the MCAS system, and the rationale behind it is very simple. The Boeing 737 MAX is slightly more unstable, so they introduced a system that should help crews avoid stalling. We think they should have informed crews about it. Boeing said it did not disclose the system to pilots in order to avoid flooding them with information. We think following that rationale is only partially justified. The MCAS is a stall prevention system, and it could indeed partially defeat the purpose of the system if you tell pilots about it and tell them how to circumvent that. But if the system is not tuned or designed correctly, you had better make sure that crews know how to deactivate the system reflexively without them having to look for the right checklists. Boeing CEO Dennis Muilenburg said that they disclosed everything necessary to fly the aircraft safely. In some sense, he is right, since the Airworthiness Directive and Boeing's Operations Manual Bulletin point to an existing non-normal checklist for deactivating the stabilizer trim and continuing to fly the aircraft with manual trim. This would have deactivated the MCAS, which is the system that pilots didn't know about. What was missing, however, was the link between horizontal stabilizer, MCAS, and the angle of attack sensor in the checklist. In our view, if you do not disclose the existence of the system or train pilots on it during their transition course, you should at least make sure this is a system that can't fail. This is nearly impossible. So it is desirable to build in some buffer in the form of additional sensors, for example, besides the left-right sensors for the left and right seat of the flight deck. We feel that Boeing has implemented a system with good thought, but the system now controls an important part of the aircraft without it having been made sufficiently foolproof, and neither are there multiple layers of protection before the system can start failing or become too powerful. We think Boeing should have documented the changes during the transition course for pilots and added explanation as to how the MCAS and STS are different and whether they even coexist on the Boeing 737 MAX. All of the above might sound extremely familiar to those who have read my coverage on the Lion Air crash, because my view on Boeing's MCAS design, information and training has remained unchanged. My view is that Boeing could have designed a more robust MCAS system that relies on more than one sensor input to trigger horizontal stabilizer motion. In not doing so, Boeing has greatly underestimated the importance of the system and the adverse consequences of system failure with regard to controllability of the aircraft. Boeing engineers undoubtedly are extremely talented, and workers take pride in building Boeing jets, but if you have an aerospace engineering background, you can only conclude that the MCAS design has been suboptimal. This does not necessarily result in a crash, but we also found the training materials and ways to increase situational awareness to be lacking. The training simulators don't even deal with MCAS failure scenarios. If you combine this with lacking documentation and inferior system design, you can only conclude that Boeing did not give flight crews the tools and knowledge to fully understand the differences between the MAX and the ING and to deal with MCAS failures. Boeing's role is not just to design, flight test, acquire certification, assemble and deliver aircraft. It also has a role in ascertaining robustness of the training materials available to those flying the aircraft. Role FAA. Currently, the role of the Federal Aviation Administration is being probed, and this has come as a shock to many. However, after the first crash with the Boeing 737 MAX, I was already noting the following: the Airworthiness Directive is a notification to owners and operators of certified aircraft that a known safety deficiency with a particular model of aircraft, engine, avionics or other system exists and must be corrected. So, it's an extremely strong sign from the FAA. At the same time, you could question why the FAA certified the aircraft with the MCAS in the first place and didn't require procedures to be outlined for the MCAS, since the administration is also in charge of certifying training programs. The FAA is likely the most capable aviation certifying administration in the world, yet they seem to know about the MCAS and did not require additional pilot training on the MCAS. The Brazilian administration did require additional training on the anti-stall system. I also added the following comment during earlier discussions with readers. People criticized Boeing, putting almost all blame on them, and while I do think Boeing should have done a far better job informing pilots and possibly designing and implementing the system. Also, the role of the FAA should be investigated to see whether they actually have the capabilities to certify aircraft that are becoming increasingly more complex. You could say that what is making headlines today, readers on Seeking Alpha were already made aware of in December 2018. In the aftermath of the Ethiopian Airlines crash, China initiated the grounding of the Boeing 737 MAX. I think there was sufficient reason to ground the aircraft as a precaution, given that Boeing had not yet rolled out the software fix that was in development after the crash of the Lion Air Boeing 737 MAX 8. One thing to consider is that China operates nearly 100 Boeing 737 MAX aircraft that it relies on to support demand for air travel, so the grounding should be viewed in the safety and demand framework rather than that of the trade war and politics. It is of importance to China that passenger confidence in the Boeing 737 MAX is not eroded any further because Airbus, OTCPK, EADSF, and COMAC simply can't support the demand for single-aisle jets by themselves. The FAA was the last administration to ground the aircraft. Why the FAA did not ground the jet earlier is not clear, but I can imagine it is because the FAA does not get off scot-free in this case. In the aftermath of the first crash, Boeing had been working on a software fix that would have turned off the MCAS in case the pilot opposed the MCAS system multiple times. The way it looks now is that neither Boeing nor the FAA has properly assessed the power of the MCAS system, and they have underestimated the consequences of the failure of this particular system. This raises the question as to how the FAA was able to certify something when they didn't understand the extent to which it affects the stability of the aircraft. The question that would immediately follow is how the FAA determined the Boeing 737 MAX was safe to fly after the Lion Air crash and issued a continued airworthiness directive after the Ethiopian Airlines crash. It simply does not add up. You could even say that the FAA, having been the last to ground the aircraft and even having issued a continued airworthiness directive, has gambled its own credibility. One thing that should also be considered is that it is said that the rollout of software fix that Boeing already planned was delayed due to disagreements between the FAA and Boeing on the extent of the fix, and the government shutdown. That said, acting FAA Administrator Daniel Elwell denied any delay relating to the December to January government shutdown. We are now seeing broad media coverage on the role of the FAA, but those who have been reading my work have already seen me putting a big question mark on the role the FAA plays here. Our conclusions and observations, which were formulated after the Lion Air crash, and have not changed following the Ethiopian Airlines crash, are the following. If the crew had identified the problem correctly and deactivated the automatic trim and manually trimmed the aircraft, the accident might not have occurred. If Boeing had put together operating procedures, checklist, and training for an AUI sensor malfunction and an introduction to MCAS in a transition course, the accident might not have occurred. If Boeing or its supplier had designed a more robust AUI sensor or MCAS, the accident might not have occurred. If the FAA had required Boeing from the start to inform pilots about the MCAS, the accident might not have occurred. If the FAA had required a more robust design for an important augmentation system such as the MCAS, the accident might not have occurred. Crew and automatization in the cockpit. Source, Avionics magazine. In the aftermath of the Lion Air crash, many blamed crew and maintenance facilities. Indeed, Lion Air does not have the best safety record. Ethiopian Airlines, however, is an airline that has good maintenance and training facilities. The captain had over 8,000 hours of flying experience, while the second officer had 200 hours. Admittedly, the second officer did not have a lot of experience, but this does not mean the flight crew is to blame for the crash. As I have noted previously, during air crashes often there is no single reason for a crash but, rather, an unfortunate chain of events leads to the crash wherein each link in the chain has a different weight. Blaming flight crews after a crash is easy, but it should also be pointed out that flight crews should be handed the right tools to operate the aircraft. I am convinced that the MCAS system design, certification, training and documentation has been lacking. flight decks have become more and more automated over the years, and nowadays everything is shown on big displays. That plays a role as well. This is not to say that flight crews do not understand the physics behind flying, but some key information, such as angle of attack information shown on the flight display and angle of attack disagree lights, are optional items. These items greatly increase situational awareness, but some airlines have decided against purchasing these optional items. In the aftermath of the accidents, the angle of attack disagree lights will become standard. These lights had been installed earlier, a malfunctioning MCAS could have been noted. Airlines will also be able to have the angle of attack information shown on the primary flight display at no cost. What remains unknown at this stage is why the aircraft had such a high speed on departure. An additional big question mark is why, despite clear instructions in the emergency directive from the FAA and in Boeing's service bulletin about turning off the MCAS, the Ethiopian Airlines Flight 302 experienced fluctuations in the vertical speed and ended up pitching down. So, while everything seems to be clear, it is still not clear whether there were additional malfunctions or complications during the flight, and whether the crew did follow the non-normal checklists for runaway stabilizers that Boeing and the FAA emphasized after the Lion Air crash, or whether the functioning or power of the MCAS has been underestimated or not understood. Conclusion: the Boeing 737 MAX crash was a tragic one, since it is highly likely that the accident could have been prevented if the software fix had been rolled out. I think the idea behind MCAS is good, but the execution, design, and certification have been poor, and that raises questions regarding the role of Boeing and the FAA. While a close relationship between the FAA and Boeing is beneficial for a smooth certification process, it does seem that Boeing has been taking over roles of the FAA in the certification process, or that the FAA has not had the capability, or sufficient information, to assess the functioning and consequences of an MCAS system failure. Keeping all factors in mind, the grounding is more than justified and possibly even came too late. The preliminary report has yet to be published. One of the things I'd like to see it shed more light on is, even if the MCAS played a role, why the Ethiopian Airlines Boeing 737 MAX had a relatively high speed. It is key for Boeing to show their commitment to safety and give certifying agencies and flight crews all of the information required to certify and fly the aircraft. Confidence in the Boeing 737 MAX and the FAA is currently dented, there is no question about that, and all civil aviation administrations will be monitoring these developments closely before they will allow the MAX back in the skies. A green light from the FAA won't be the most convincing sign that the MAX is meeting safety guidelines, but a green light from other agencies, such as the Chinese and European regulators, will play a key role here. One thing to keep in mind is this: the way aircraft design has always worked is that an aircraft is designed and certified, and in the case of accidents or incidents, investigations are carried out and design, manufacturing and operation recommendations are made and implemented. The Boeing 737 MAX accidents are tragic because lives were lost, but we should also keep in mind that this industry, like every other industry, has always functioned in this way. What makes the Ethiopian Airlines Boeing 737 MAX crash extra painful is that, to me, it does seem like that if almost all parties involved had done a better job, a fatal crash could have been prevented. If you enjoyed